This would be the hypotenuse times the sine of theta, and this one would be the hypotenuse times the cosine of theta. So I take my force diagram there, I decomposed. And so we have going up, y cosine of theta, and going to the left, y sine of theta. What's next?
Equations.
All right, how many equations will we have?
No. Yeah, two.
You settling with that? Is that your final answer?
Yes.
Okay. All right, so my two equations. Again, F equals ma is my template. So I'll have my forces on the left-hand side, mass times acceleration on the right. Someone take a shot. But let's just hold on a moment, give other people a chance.
Okay.
Though I appreciate your wanting to do that. Someone, prevent Louis from having to do this. Sorry, Luis. Right. It is Luis, right? Not Louis. Okay. Sorry about that. Probably won't be the last time I mispronounce. Don't let Luis or Ethan answer this question. Beat them to it. Take chances. Make mistakes. Get messy.
F equals y cosine theta minus e. Or not F equals, but y cosine theta minus e equals n. And equals 0. I don't know.
You said equals.
I said n and then I said 0.
Okay. Because there's no acceleration vertically, so yeah, that's absolutely right.
Okay.
I see you skipped the make mistakes part of that, but that's okay.
I feel like I was gonna skip that.
And the other equation?
Wouldn't it be negative y cosine in the direction that we put j at? I take it positive.
You're right. All right, this is not, if you went with this, it would not end up being a wrong, you still get to the right place because it's equal to 0, but yep, given the convention, sign should be the other opposite. The other equation? Oh, don't let Luis, Ethan, or Kelly answer this one. Take a chance. Somebody go for it. Dazzle us with your willingness to participate.
Y sine theta equals mass times acceleration.
What type of acceleration are we talking about here? All right, and there we are. So, what's next after equations of motion?
Substitution.
Yep. So for what do we have an independent formula?
Weight.
And
Normal force.
no, we don't. Definitely do not have one. The normal force is always problem dependent. All right, well, at least we get the weight done. So this one we've got, so mg is equal to y cosine theta.
Oh, it's acceleration.
Yeah, we have a formula for centripetal acceleration. I gave you speed v, so probably the v squared over r is the appropriate one. So from this, we have y sine theta. I'm going to write this slightly differently. Nah, I'll keep it as is. So y sine theta is equal to m v squared over r. And now solving, I'm gonna most people who are solving this, they flash back to whatever math class, they solve for y in one formula and plug into the other. Absolutely fine. I'm gonna solve it a slightly different way because these problems throw up enough. I have y sine theta is equal to mv squared over r. Just rewrote that. And then as long as I divide both sides by things that are equal, the math people are okay with it, as long as it's not 0, because again, they haven't figured that out yet. So I'm going to divide the left-hand side by y cosine theta. And I'm going to divide the right-hand side by something that's equal to mg. Denominator are equal, as it's written right there. And so the math people say this is legitimate. The reason I do this is my y's are going to cancel out. If you would substitute, you would get to the same place, but the wrong one. Y's cancel out. Matter of fact, the mass cancels out also. And I'm left with, well, what's sine divided by cosine? Sine over cosine is tangent, which is then equal to v squared over rg. So my speed squared must be equal to rg tangent of theta. And so v is the square root of rg tangent of theta. And now let's plug and chug. Oh, wait, we were solving for theta. So oops. So theta is the arctan of v squared over rg. I guess coming from there. The two basic introductory problems are you have theta and solve for v, or you have v and you solve for theta. Now it's plug and chug, so I get the arctan of 30 squared over 100 times g, which is 9.8. And let's say 40 degrees. 41.37.
42.56.
42.56. That's a pretty steep angle right there. So 45 is like that, so this would be slightly less than the 45-degree angle. There are not a lot of roads out there with that steep. NASCAR track, the one in Charlotte, is like 18 degrees. I got some nods over there. So, take that as you have authority. All right. There is a track in Germany that's no longer used, but which is at the steepest part, I think 72 degrees. Now, if you drove slower than 30 meters per second, what would the car do?
Friction.
All right, friction would definitely kick in, but if it's a frictionless track, or as I did in one test, Mr. Freeze got to the track first, sprayed it, made it frictionless. What would happen to it?
Like fall off, like kind of slide off,
Which way would it slide?
like towards the center.
Yeah. So if you're going slower than 30 meters per second, it wants to slide towards the center. If he's going faster than 30 meters per second, yeah, he wants to move towards the top. So that angle is the ideal angle for that radius and that speed, so that, and that planet, so that it could take it without any friction at all. However, based on that, if we keep that angle the same but change the speed, friction will act on it, either up the ramp or down the ramp, depending upon which way opposite of which way it wants to go. So my force diagram would change if he travels greater than 30 meters per second. So if v is greater than 30 meters per second, I have an additional force going in that direction. If less than 30 meters per second, my force diagram friction's going like that. We will have, either way, we have to break friction up in addition to the normal force. And here's the quick and dirty for it. Once you've done one of them, the other one is simpler. Because these are perpendicular to each other, the sine cosine flip. So my friction, in this case right here, is to the right and up. So this is going to be the friction times the sine of theta. And this is friction times the cosine of theta for this scenario here. Again, because they're perpendicular. There are other ways of getting to the exact same place, but that cuts down on some of the thinking. My equations of motion now change. And it's just a fun little math problem. Some of you are just gonna have to take my word for it for right now. But later on, you'll go, oh wow, that was fun. Sorry, Luis, you have to look like you're ready to see the math or do the math.
No, I was just gonna say, why not just change the axis?
The acceleration is still that way.
So, okay.
Yeah, so if you change the axis, suddenly acceleration has components, and one of the equations is not equal to 0, and you have now quadrupled the amount of math you have to do.
Okay, that makes sense.
But if you enjoy the math,
No.
anyway, have a great weekend.